Hello, this is Tim Kearns from the Great Lakes Observing System, and we're bringing you live another live stream from GLOS, as we like to be called, about the search for the missing plane. In 1968, an NCAR plane went missing. It took off and had two pilots and a graduate student on board and disappeared over the waters of Lake Superior. And that was 56 years ago. And the search is still on. It has never been found. Some debris washed ashore over the years, but the closure and the final chapter of that missing plane has never been really closed out. Now, Smart Ships Coalition and Michigan Technological University, Great Lakes Observing System, and industry partners and many others got together in 2024 to lead a mission to search for the plane. Covering over the course of 3 days, a number of vessels and equipment went out onto Lake Superior, looking and scanning the bottom using multi-beam and single beam and side scan technology. These are all remote sensing devices that can scan the bottom, looking for features, targets, other interesting objects, any clues that might reveal missing debris or aircraft itself. Now, that was 3 days of survey in September, and then we spent many weeks and months during the fall and winter evaluating all of the data, making some models, and identifying a list of potential targets. Now, what we're doing now, and the reason that we're coming back to you for this live stream, is that the crew is back out in the field this week looking at those targets, because not everything says this is an aircraft part. It might be just a bright spot on the map, and that might look like something, but we could be probably not a lobster pot, but it could be some sort of fishing equipment, could be an oil drum that fell over, it could be, who knows, maybe a car, or it could be just a rock or a shadow in the data. And so the crew this week is out there again with some specialized equipment, looking at that data, sending down cameras and remotely operated vehicles to have a look at all of those targets to find out, all right, is this missing aircraft part or is this something else? Now, if it's something else, then great, we can document it and we know what it's there. If it is missing aircraft part, then now we've got an idea that, all right, maybe this missing plane has been found, or at least parts of it. So in just a minute, we're going to cut over to Travis White, who's the lead researcher on this project. He's in the field on the RV Soliton with a number of other crew. It's only about 26 feet long, I should say. And they're out there with this equipment looking at the targets. And I wanted to just maybe share with you the imagery that we get, and we're going to show this tomorrow. Probably we're going to be doing another live stream. We're going to show what this data actually looks like, so you've got a better understanding of, well, why can't they just figure out if it's from the data that they collected last summer? You'll see it's like a radiologist, like a specialized doctor looking at an X-ray or an MRI. You really need to have a trained eye to look at this stuff, and sometimes it just gives you a clue that something's there, and you need to go in and do some further investigation. So that's exactly what's happening this week. Further investigation on what these objects that may or may not be on the bottom of the lake actually are. So I think Travis is standing by in the studio here. So we're going to cut over to the RV Soliton, and there's Travis and 3 or 4 other people on board. Travis, welcome back to the live stream for the Lake Superior missing plane search.
Hey, Tim, good afternoon. It's great to be back with you here. We're having a great day out on Lake Superior. It's yet again another beautiful, flat, calm day. So we lucked out last fall when we had such great conditions for our initial multi-beam search. And we're lucking out again today as we do some of this target investigation work.
Great. All right. Well, who have you got on board? And tell us a little bit about what happened yesterday and what's going on today. And I think what everybody really wants to know is, what are the weather conditions like for you out there?
Yes. Yeah. Well, great question. So to kind of queue up, what we are doing this week, last fall when we did our survey, we collected about 45 square miles of multi-beam data across the lake bed using a sonar mounted on our surface vessel and on an ASV, an autonomous vessel. And today what we're doing is we're coming back and revisiting some of the specific points within that data that we collected that stood out to us. And today we're using a towed side scan sonar on this vessel to do just that. And what this is giving us is a much closer look, so higher resolution by looking closer at these pinpoint targets. So yesterday we spent most of the day getting our equipment mobilized, which we're going to show you in a minute. On the back deck, we've got an electric winch with a data cable spool and our towfish instrument, which is about a 1 meter long, sort of a bullet shaped, torpedo shaped sled that carries our side scan sonar. And the way we're deploying this is by deploying that reel down to the depth of our target, and we're controlling our speed and the depth of that cable very precisely, so that we're pulling that sonar about 5 to 15 meters above the lake bed, to give us the closest and most high resolution look that we can possibly achieve with side scan sonar. And today we're basically out here going from point to point. So we've got 14 discrete targets out on Lake Superior within that 45-mile square area. And we're running from point to point, making sort of a milk run between all of these targets to do this close-up look. So with me today, I've got Wayne Lizardi from the state of Michigan. He's a marine archaeologist, and he's been leading all the historical documentation efforts, as well as research around this NCAR aircraft. And there's about a 4-inch thick volume of documentation sitting next to me that he's compiled since we've begun this project, including a schematic of all the parts on the aircraft, which you alluded to, Tim. We're trying to find sonar targets that match pieces of this aircraft, whether it's an entire intact aircraft or more likely, sort of scattered debris or bits and pieces. So behind him, I've got Jamie Anderson, my colleague, who's running our towed sonar. He's basically controlling the winch that's letting that instrument in and out, and he's also watching the data as we're collecting it, so that we're basically observing in real time as the vessel is driving over these targets. We're watching the return on that sonar data coming back to the screen back here. And the four of us, our last participant, Jenna Debris, is our undergraduate student intern, and she's been working on this project specifically for the past 2 years now. So we're all watching this data come in real time and discussing and putting our heads together to decide if these little blips are potentially something man-made or geological or nothing at all. And I think what you'll hear from the crew here in just a minute is that it's really interesting, comparing these targets that we found in this wide area search last fall to what we're seeing today on this close-up look. And I don't want to give any spoilers away here, but everywhere that we marked a target in our wide area search last fall, we have seen something today, which has been very interesting. So I think I'd like to pass the torch here to Wayne to talk a little bit more about the aircraft and kind of the importance of why we're doing this target investigation work. And then we'll actually pull the instrument out of the water, and Jamie and Jenna will show you that and talk a little bit more about the data that's being collected.
Hey guys, thanks Travis. Yeah, I'm the state's maritime archaeologist with the Michigan Department of Natural Resources, and I've been working with Travis and the crews up here. I was fortunate to come up last September when they acquired all of this acoustic information, and now we're ground truthing some of those that we prioritized over the winter. And so far we've looked at quite a few. Today's been a terrific day, and everything working on the water is directly dependent on the weather conditions on the water, and it's just been terrific. The airplane, the Beechcraft 6580 that went missing here 57 years ago, was a relatively small airplane. It was probably about 35 feet in length with a 50-foot wingspan, and almost certainly it's broken based on the amount of debris that came ashore right after the accident occurred, and that has been found over the last nearly 6 decades since. So we're probably not going to find, a fully intact airplane on the bottom. We're going to find maybe pieces and parts of it. And so that makes it infinitely more difficult because they could be very, very tiny. And because the water is relatively deep here, we're in 251 feet of water right now, and it only gets deeper offshore from here. it could be very well concealed on the bottom, especially with the geologic features that are here. There are glacial grooves and striations all over the bottom. There are sand beds and giant ripples, and then there are just rock debris fields everywhere. And so any kind of cultural material or human-made objects can really blend into that pretty easily. So that all said, we looked at a bunch of targets. We picked out 14 that looked very promising, and then we've looked at about 10 of those already today.
Tim, would you like to jump in, or would you like me to have Jamie and Jenna introduce the towfish instrument?
Yeah, that would be fantastic. Let's get the other crew to share some details on what they've got, what the equipment that you're deploying, and I don't know if you're able to move the camera around, or maybe they just bring the gear over to you.
Okay, I'm going to point it right at them.
Going to talk about this before we pull it up?
Sure.
Okay. So this is what you're looking at is a representation, electronic representation of the towfish that is hanging right now about 10 meters below the boat. We're not actually in motion, so it's not out behind, but it's still enough to kind of show you how this is represented. So this is a towfish that uses that collects side scan sonar data in a couple different frequencies. And so if this is the direction of the boat, this is the center line of the boat, and the towfish that's being towed, this is looking out to the sides, right? So even right now, it's 50 plus meters off the bottom, and we're just drifting. It's still collecting data of the bottom of the lake here, out to 200 meters each side. So which is pretty spectacular. It's a pretty nondescript bottom. You can see little ripples and rugosities. So we change that range, right? Side scan is all about power and how you're using that power. If we want to see out really wide, we have a certain amount of power. We can commit to that and gets us a certain resolution. If we want to constrain that power to a much smaller area, like Travis mentioned, when we're running this close to the bottom, between 10 and 15 meters from the bottom, then we constrain that power to that smaller area and therefore get a higher resolution. And we have a couple different frequencies. Do we want to show a couple of the candidate things?
Yeah, I think so.
So just a couple of the targets that we've quickly identified as we've been cruising around. This one we made 3 passes on, and I think we quickly determined that this is just a big boulder. But the first pass the data did not convince us that it was just a boulder. It looked kind of angular. And so on the 2 subsequent passes, this one definitely was a boulder. This is another kind of a discrete object sitting on the bottom. It's got some scour. We think this is another boulder as well. Another something on the bottom, we're not quite sure. This is a group of fish that's off the bottom in the water column, which is the dark area, the area that's underneath the towfish in the vessel, but not the lake bottom itself. So as we kind of look at this waterfall, as we're cruising along, objects show up from the top to bottom as this waterfall moves through. And when we're interested, we just give it a right click and it grabs that. But then we'll look at all of this back in the office again, with higher resolution tools for making measurements, and we can use the length of the shadow, the acoustic shadow of these objects to determine how high they are off the lake bottom, so a height measurement. And we'll start to make all those measurements as we re-review this data in a little more of a controlled environment that is a boat. Want to bring it up?
Awesome. Were you guys able to see that screen okay?
Yeah, not really, actually. We could see the metadata on the side, which is always a lot less interesting than the pictures.
Yeah, it's one of the challenges, with this data and the representation is we're using this sort of amber color palette, which works very well to our eyes to be able to see these differences between hard reflective objects and the softer kind of background of the lake bed. And, the amber palette really pulls out those white colors as these hard reflective returns, whereas the lake bed surrounding is kind of this real dull, dark brown. So it almost looks like, from the camera's perspective here, probably just a dark computer screen in the absence of anything interesting.
Yeah, that's okay. Maybe send me a few screenshots, and then tomorrow when we come back on the live stream, I'll share my screen and show everybody who dials back in so they can see what you were looking at on your screen, and they'll get a little higher resolution.
Fantastic. So we'll do that, and I think the last thing we could do here is if Jamie and Jenna were willing, we could pull this towfish up onto the deck and just show you quickly what our instrument looks like that we'll be towing around for the rest of today.
Great.
Ready? Come on. 5 minutes. Yeah. And
Okay, we just broke the surface with the instrument here. So that was, as you were hearing, Jenna was calling out to Jamie, operating the winch, so we knew the depth as it was approaching the surface. And now Wayne's recovering it. It is actually quite heavy, so we have to kind of use a little bit of muscle here when we're pulling this in and out. But what you can see is it's sort of a torpedo shape, so it's very hydrodynamic. And the fins on the back of this help to align it with our direction of travel, which basically orients the side scan sonar array coincident with our direction of travel, so that we're looking both to the left and right side of our vessel as we're cruising along. So Jamie might be able to point those out a little bit, just so you can see where that element is.
Yeah, so I can tip this a little bit. Hopefully I don't tip it off the boat. Turn it a little bit so you can see it. There we go. So this is one of 2 side scan sonar elements. They're pretty flush with the hull to make it nice and efficient in the water. But there's one of these just like this on the other side. Again, it's looking down and away, just like you saw in that image, right? So never straight down necessarily, side scan. And then this big monster is just a heavy lead weight. This is quite heavy by itself, but this helps us get it into deeper water. So the 2 elements, just a heavy nose, a heavy tail, all the electronics internal, and then the data cable. And of course, a safety cable in case this gets into something, a net or the bottom or some other thing, this shear pin would fail and allow the whole thing to then rest off this tail point and allow the whole thing to kind of flop down and release from whatever it's tangled up on. Fortunately, that's not happened to us today. So it operates pretty normally.
So I think that's really what we had to show you all today, Tim. And basically, we're going to continue to investigate the rest of our targets. I think we have 4 remaining at this point.
Okay. All right. Well, thanks very much. I really appreciate you guys taking the time. And thanks to you and Jenna and the other crew to show us what you've got and what you're doing. And also a beautiful day on Lake Superior, which we're happy for you, of course. You're not out there struggling in heavy seas. I think we'll check in tomorrow again, Travis. So we'll see how things have gone and if you've identified anything that could be of more interest or requires additional investigation. So thanks very much, and we'll check in with you tomorrow.
Great. Yeah, sounds good, Tim. Thank you very much. We'll see you tomorrow.
All right, sounds good. All right, for those of you who are still on the live stream, I wanted to share with you, there's 4 reasons for why we do this, right? There's yes, we're looking for the plane. We're looking for debris, and we want to find this. It's been, decades that this plane has been missing, and people want answers. We're also doing it to test new equipment, and not just new equipment, but methodologies, processes, the techniques that are involved in doing this type of activity in the Great Lakes, of which there hasn't been a lot of sort of a coordinated multi-group effort to look for something specific. There's over 6,000 shipwrecks and planes, not planes, but wrecks, I guess you could say, in the Great Lakes. And I think only 1,800 of them have been identified and discovered. So, there's a lot of wrecks that are sort of waiting to be discovered and documented and preserved in many cases. The scuba diving community is very interested in exploring this area, and the scuba diving community generally they're conservationists. They want to preserve this, these materials that are on the lake floor for others to visit, but also to provide some closure. The third reason that we're doing this actually is to support Lakebed 2030. Lakebed 2030 is a region-wide initiative to survey the Great Lakes in high resolution comprehensively. It's never been done before. Some cases we've got soundings that are 500, 600 meters apart, going back to the 50s and 60s. So very, not that it's bad data, it's just old data, and it's not been collected to modern standards, and it's not comprehensive. So we're going to show you some high resolution models of the survey area from 2024. We'll show you that tomorrow on the live stream, but that's the type of model that we want to get, this elevation model or bathymetry model. That's what it's called on the lake floor, of what it looks like if we were to drain all of the lakes. And we just don't have that picture in high resolution for the entire Great Lakes, and Lakebed 2030 is an initiative to try and do that. So this effort, collecting even these 45 square miles, goes a long way in supporting Lakebed 2030 initiative. And then really the last reason why we're doing this, and maybe even the most important one, is to provide some answers for the families of those crew members who are on board the plane that went down in 1968. Many of them are still alive, very, very interested. They're following this search. And hopefully if we can get some answers for them, then maybe it can provide some closure for them as well. So at the end of the day, this is human beings who are missing, and this is a big deal. So we'd like to do our part to support that. That's it for the live stream today. We're glad that you tuned in. This will be posted on the GLOS YouTube channel at Real GLOS. Check it out. We've got lots of videos, other live streams that we've done in the past, interviews that we've done with researchers and recreational users around the Great Lakes. So if you're interested in learning more about GLOS or learning about the platform that we offer all of this information on, it's called Seagull. You can check out seagull.app or seagull.app. And then, of course, learn more about us at GLOS.org. And I saw that our producer also posted lakebed2030.org if you'd like to learn about the mapping mission for all of the Great Lakes. Feel free to get in touch with us, underwater@glos.org, and we'd be happy to answer any questions. And feel free to dial into the live stream tomorrow, where we'll be evaluating the final closeout of this mission in 2025 and talk about next steps.